Hi dear students, we are going to study about minors, cofactors and cofactor matrices. And before starting that one, to find the minor, we should use the square matrices. So we are going to work on square matrices to get the minors. So the minor of an entry Aij, the minor of an entry Aij, this is important here, is denoted by Mij. So the minor of Aij, the minor of A24 is going to be denoted with M24. This is the first part. And the second part is Mij, the minor of Aij, is the determinant of the square matrix formed when we delete the ith row and jth column. So if you are looking for 2, 4, minor of 2, 4, and in the matrix A, here it is, matrix A, you are going to delete the second row here. You are going to delete, and the fourth column you are deleting, which means that you have new matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, and the determinant of this matrix is going to be equal to 0. And to prove that one, you can rewrite the Sarus rule you can use to find the determinant of this matrix. And 4, 5, 6 we are going to write here. Let me use different color. Then here, these are, firstly I'm writing the pluses. 1 times 5 times 9. I can write like this: 1 times 5 times 9. 1 times 5 times 9. 4 times 8 times 3. 4 times 8 times 3. 1 times 4 times 9 is equal to 45. 4 times 8 times 3, it's equal to 4 times 8, 32 times 3, it's equal to 96. And 7 times 2 times 6, which is equal to 7 times 2 times 6, is equal to 7 times 12 is equal to 684. It has to be. Okay, then these are the pluses, which means that 45 plus, 96 plus, 84 part. And the second part is minuses. Let me use different color for that one here. 7 times 5 times 3, 7 times 5 times 3, which is equal to 105. 7 times 5, 35 times 3, 105. 1 times 8 times 6, 1 times 8 times 6, which is equal to 48. And the last one is 4 times 2 times 9. 4 times 2 times 9, which is equal to 8 times 9, which is equal to 72, it's going to be. And then if we add, these are like 105 plus 48 plus 72. Okay, then the sum here, it's going to be equal to 48 plus 72, which is equal to 120. 120 plus 105, it's going to be equal to 225. The same one down here, it's going to be equal to 96 plus 84. It is 90 plus 90 when you send the 6 to this side. 180 plus 45, which is equal to 225. It's going to be. So the minor M24, it's going to be, first let me write the 225 correctly here. Then M24 is equal to 225 minus 225, which is equal to 0. It's going to be. So the minor of the entry, A24 is M24, which is equal to 0. It should be. Okay, let's continue with the other exercise here. Find all minors of the matrix A. Here, the matrix 3 by 3 matrix. And I have already prepared here 9 matrices because of all the entries here. There are 9 entries, so we are going to find 9 minors. For each entry, we have one minor. That's why we are going to calculate 9 different entries here. So I'm going to continue with the M11 here. M11, it's going to be when the first row, first column deleted, the rest of them, the determinant of the rest of them we are going to get, which is equal to minus 1, 3, 1, 4. And M11, it's going to be equal to minus 1 times 4 is equal to minus 4. 3 times 1 is equal to minus 3, which is equal to minus 7. It has to be. This is M11. What about M12? M12 is equal to first row and second column deleted. So the entries are 2, 3, 0, 4, which is equal to 2 times 4 is equal to 8, and 0 times 3 it's equal to 0, which is equal to 8 it should be. And I didn't write here, but if you remember, the determinant of A, B, C, D matrix was equal to determinant of it, A times D minus B, C. That's why I'm crossly multiplying like that. Then we are going to continue with the M13, which is first row and third column deleted. Then the entries are 2 minus 1, 0, 1, which is equal to 2 minus 0, which is equal to 2. It has to be. Minus 2. These are all the minors of the matrix A. Here it has to be. Okay, now we are going to continue with the cofactor of the Cij. Is the real number defined the terms of the minor Mij as Cij is equal to minus 1 to the power of 1 plus I, which is the row number plus column number, times Mij. So it means that there are two possible cases here. If it will be 1 or minus 1, which means that Cij either will be equal to Mij, or Cij, it will be equal to minus Mij. In which condition Cij is equal to Mij? If I plus j, the row number plus column number, if it is even, they are equal to each other, because when the power is even number, this is going to be plus 1, and 1 times Mij, it's going to be equal to Cij, which is actually, instead of writing these arrows, I can show is equal to sign. Cij is equal to Mij in this case, and Ci plus j, if it is odd number, then Cij, it should be equal to minus Mij. And the matrix made by the cofactors is called cofactor matrix. Here is the example of it, and we are going to find the now cofactor matrix in the question. Here, find the cofactors of matrix A. This is from example 4, and write the cofactor matrix of A. So here, these are the minor values, and from the minor values we can easily get the cofactor values. So M11, it's going to be here, M11 is equal to minus 7 when you say. Then C11, it should be equal to minus 1 to the power of 1 plus 1 times M11, it should be, which means that C11 is equal to plus, because minus 1 to the power of 2, plus 1 times M11, which means that C11 is equal to M11, it becomes. So when you write the cofactor matrix A, you are writing first the M11, which is equal to minus 7. Then M12, it should be equal to minus 8, because minus, here it should be like this, C11. Then C12, it should be minus M12. Why? Because the powers are odd. the sum of the powers odd, which is equal to minus 8 here. The sum is even, so directly you are taking. The sum is odd, you are going to make negative, which means that 1. The sum is even, directly you are taking. The sum is odd, get the negative 1. The sum is even, get directly. Sum is odd, then sum is odd, get the negative 1. Sum is even, directly you may get. So this is the cofactor matrix of A, it's going to be. Okay, finding the determinant with cofactors, we are going to continue. Cofactor expansion it is called, and here there is a formula cofactor expansion for 3 by 3 matrix. You are going to, this is the row cofactor expansion, which means that here you are choosing one of the ith row here, and with respect to that row you are writing all the entries one by one. Let's say if we choose the first row, first column, or if we choose the second row, then cofactor expansion is going to be, for the determinant of A, it should be equal to AI. Here I have chosen the second row, A21 times C21 plus A22 times C22 and plus A23 times C23 it has to be. So this is the cofactor expansion with respect to row. If you do the same thing for the column, also you can do that one. And with the same logic, it is working. I'm going to solve one example and I'm going to finish this one now. Here, firstly, I'm going to choose which row I'm going to use for the first row. Actually, it is written here for the matrix A along with the first row it says. So it means that I'm going to choose the first row entries here, which means A11 is equal to minus 1. And so when I close the A11, I'm going to find the M11. M11 is equal to going to be 1 and 3 and 2 and 1, which is equal to, and 1 it should be equal to 1 times 1 it's equal to 1, 2 times 3 is equal to 6, which is 1 minus 6, and 1 is equal to minus 5. It has to be. Then A12 is going to be, A12 is equal to 2. Then here, so by the way, I forget here, C11 it's going to be equal to, when you add the powers it makes 2, so directly, which means that power is even, so directly you are going to get. If the power is odd, if you remember, you are going to get negative of it. So for the entry A12, the minor is 1 2. When I change this one here to 1 2, first row, second column, the entries are 2 3 3 and 1. It's going to be, then it's going to be equal to M12 is equal to 2 times 1 is equal to 2, 3 times 3 is equal to 9, so 2 minus 9 is going to be equal to minus 7. But C12 is equal to minus 7 it should be, and C12 is equal to 7 it has to be. And this is the last one, A13, it's going to be A13, since it's equal to 4. I'm writing the directly, I'm not going to clean the part, so M13 is equal to 2132, it should be 2132, which is equal to 4 minus 3, which is equal to 1. It's going to be, since the sum of 1 and 3, which is positive, which is even number, M13 is equal to C13, it has to be, which is equal to 1. Now I found all the cofactors in the same row, and I know the here, as you see, I know also the entries. So determinant of the A is going to be equal to A11 times C11 plus A12 times C12 plus A13 1 3 times C1 3 it's going to be, which is equal to A1 1 is equal to minus 1, and then C1 1 is equal to minus 5, then plus A1 2 is equal to 2, and C1 2 is equal to 7, plus 4 times A1 3 is equal to 4, C1 3 is equal to 1, which is equal to 5 plus 14 plus 4 it's going to be, which is equal to 23 it should be. This is the along the first row cofactor expansion. In the class we are going to solve along with the respect to second column, and we are going to finish the video here.